So welcome everyone. Thank you for coming. I have the huge honor of introducing Sofia Gluskin. Sofia is an Archibald Avian Ecology intern. Sofia got her BS in ecology and evolution with a minor in psychology from University of South Florida. Previously, she has been an Ernest Hollings scholar at the Monterey Bay National Marine Sanctuary, where she studied sea urchins. And then she didn't want to study spiny things or be around spiny things ever again. So she came here. There's and discovered hogplum. But Sophia's been awesome in the lab. She's out there every day looking for nests, doing all the work that we have to do in addition to her research. And I'm really excited for her to give a talk here about her project. I have to say that Sophia's project is really ambitious, but at the same time explores something that's really unknown about Florida scrub jays, and that even with the 56 years that we've been studying Florida scrub jays here, we haven't really studied. So much so that we are hoping to actually continue collecting data next year, because we thought that this was a really elegant way of collecting data behavior that hasn't been studied in Florida scrub jays. So with that, Sophia, take it away.
All right. Okay. I haven't actually tried this clicker yet. So is it just that? And then laser pointer is the middle? All right, cool. And then mic is good? All righty. Hi, everyone. Thank you guys so much for being here today. My name is Sofia, and today I will be telling you a bit about my independent project titled Post-fledgling Movement and Survival in Florida Scrub Jays. So as birds grow and develop throughout their lives, they encounter many different challenges, circumstances, habitat requirements, and ultimately reasons for death. And for my project in particular, I wanted to focus on the highly transitional and arguably the most critical life history stage of all, post-fledgling period. So the post-fledgling period is the stage of a young bird's life beginning as soon as it leaves the nest, and in migratory birds ending when it departs for migration or settles for the winter. And for non-migratory birds, the ending is marked by the point at which the fledgling gains nutritional independence from their parents. And this period has strong influences on population dynamics, primarily due to high mortality rates as the result of predation and limited fledgling mobility, especially during the early fledgling period. However, this period is often considered to be one of the least understood phases of a bird's life. And there are various logistical reasons for why this is the case. First off, fledglings are very cryptic, making them difficult to relocate compared to nestlings that can be studied in the nest and adults that are less enigmatic. And also, in migratory species, fledglings typically disperse large distances from the nest within just a few weeks, making them difficult to study, especially when using resighting methods. And so as a result, most post-fledgling movement studies are conducted using radiotelemetry and on migratory species. And while there's no doubt that radiotelemetry is a highly useful tool for studying the movement of individuals, it's also limiting in the sense that radio transmitters can usually only accommodate for small sample sizes due to cost and maintenance of equipment. They may cause potential harm to fledglings, and they tend to lack the ability to provide highly precise location data that's needed to understand smaller scale movements of resident species. So now focusing on the study species for my project, the Florida scrub jay. So Florida scrub jays are non-migratory and they engage in year-round territorial behavior, meaning that they stay in the same general area for their whole lives. And these characteristics make Florida scrub jays a really great candidate for studying post-fledgling movement, habitat use, and survival, because these jays are really reliably found in a relatively small area, which allows us to study fledgling movement and development over time much more accessibly compared to migratory species. And through the literature, we know that only 35% of fledglings survive through their first year, and that predation is the primary cause of their mortality during this time. And while nestlings and adults have received the majority of attention in Florida scrub jay literature, comparatively little is known about fledglings and their behavior, and in particular, the movement and habitat use of post-fledgling pre-independence Florida scrub jays has not yet been investigated. So rewinding a bit to earlier in this year's breeding season, while we had been discussing movement, the lab noted that in the past, fledglings from the same brood have been observed spending time both close together with their siblings and far apart from one another. And there are pros and cons to both of these strategies. On one hand, being far from your siblings can prevent whole brood loss if a predator comes along and you're not able to get away because you have low mobility. But you also might get fed less than your siblings if you're too far from your parents while they're closer. And on the other hand, if you're close together, you can benefit from aggregate group effects, such as having more eyes to look out for predators. But again, larger, noisier groups of fledglings may also attract more predators. So I was curious to see if there was a relationship between how far fledglings stay from their siblings, otherwise referred to as inter-individual distance, or IID, and their age and survival. And I also wanted to see how scrub jay fledgling distance from the nest changes over time. Increasing distance with age is really well documented in many other species of birds, and I was just curious to see if this pattern is reflected in Florida scrub jays as well. And getting into some habitat use specifics, we know that the optimal height of oak shrubs for Florida scrub jays is 1.2 to 1.7 meters, and that they especially prefer areas that contain both shrubs at this optimal height range and open sandy areas, which are achieved through having a regular fire return interval of about 8 to 20 years. And also, it's well known that habitat needs of adult birds can significantly differ from those of young as their priorities change throughout their life stages. And so I was interested in investigating how Florida scrub jay fledglings utilize their surroundings through the post-fledgling dependence period. So now moving into my predictions. First, I predicted that fledglings would maintain both lower inter-individual distance and lower distance from their nest during the early fledgling period, and that both inter-individual distance and distance from the nest would increase with age. And this is because as fledglings grow older, their mobility increases, so IID and distance from the nest are likely to increase as well. And I also predicted that fledglings who were consistently found farther away from their siblings would have lower survival rates compared to those who were found closer to their siblings. And for my habitat use predictions, I expected to see that as fledglings grow in age, their position in the vegetation would become taller, their concealment levels would decrease, and the scrub height surrounding where the fledglings are found would become more variable with preference for that optimal medium height. And this is because for much of the post-fledgling period, especially early on, fledglings tend to just sit in a concealed location and wait and beg to be fed by their parents. And then as fledglings become older and more mobile, they're able to reach higher, more diverse vegetation. And so in doing so and exploring their surroundings, they become much more visible and have less of a need to hide from their predators because they can evade them with increased mobility. Okay, so now moving into my methods. In the bird lab, part of the already existing protocol is what we refer to as weekly fledge checks. And what this entails is visiting a territory with young starting at day 17, which is when we expect young to begin fledging from the nest. And then we spend up to an hour searching for fledglings. And we repeat this every week at all the fledge territories until fledglings are 55 days old. And the reason why we stop at day 55 is because that's when we start taming in the lab, which would affect fledgling movement as we tame them at a specific desired location. And if a fledgling is not detected after an hour, they're marked as not detected. And then after 3 weeks of no detections, the fledgling is assumed to be dead and is no longer searched for. And so to locate fledglings, we use behavioral and auditory cues. So adults typically scold with increased intensity as fledglings are approached. So you can see some adults in the yellow circles here. And then we're often able to use this behavior to identify that fledglings are nearby and pinpoint their locations shortly after. And we also toss small unsalted peanut bits to adult jays because adults often carry food directly to their young, and then we're able to follow these food carriers to locate the fledglings. Also, fledglings make a loud, distinct begging sound while begging and being fed, and this helps make them a bit easier to detect as well. And so here is a short clip of what it sounds like when a fledgling begs food. Hopefully, you can hear it. Kind of quiet. Well, well, you can hear it a little. All right. So to give you guys a little bit of a feel for what it's like for us searching for fledglings every day, here's a picture of what it looks like kind of when we're out in the scrub. And if you haven't seen it yet, here's the fledgling. Next up, we're going a little harder. If you haven't seen it, there he is, right there. You can see that little orange band. And lastly, this one actually has two fledglings right next to each other in the same bush. So for my project, we added an extra component onto the weekly fledge checks to gather more data than whether they were simply just detected or not. So once we located a fledgling, we dropped a point at the location where they were first detected on a designated layer within ArcGIS field maps, and each fledgling point contained information on the date and time, the location, the territory that the fledgling was from, or the natal territory, and the unique band combination of the J, or the JID. How the fledgling was detected, either confirmed visually if they were only heard or by repeated food carries to a certain location. The fledgling's position in the vegetation, if they were on the ground, the bottom of the shrub, the middle, or the top. How concealed the fledgling was, either if they were very concealed, moderately concealed, poorly concealed, or completely exposed. And lastly, the height of the scrub surrounding the fledgling within a 5-meter radius, whether it was generally open sand, if it was short scrub, 0 to 1 meters, medium scrub, 1 to 2 meters, or tall scrub, 2 meters or higher. And over time, as my layer started to fill up with fledgling detections, and we used a gradient of pink smiley faces for the points, with the darkest pink smileys representing the most recent detections, started to look a bit like this, and this, and this, until eventually the pink smiley fledgling detections spanned across the whole study area. And so in total, with the help of the Bird Lab, we dropped 499 total fledgling detection points. And of these, we had 48 fledged groups from 47 territories, with one territory that had a double brood. And in total, I had 110 fledglings in my study. So now getting into my results. First up, we have inter-individual distance versus fledgling age. So on the x-axis, we have age in days, and on the y, we have inter-individual distance in meters. And what we found is that age has a slight positive correlation with inter-individual distance, but this relationship is only marginally significant. So what this means is that while IID does seem to increase slightly as fledglings grow older, overall, the distance between individual scrub jay fledglings remains pretty constant from when they're 17 to 50 days old. And so next up, we're going to look at average inter-individual distance by fledgling survival. So on the X, we have whether a fledgling survived to day 55, no or yes. And on the Y, we have that fledgling's average inter-individual distance. And we found this by averaging out the distance that each fledgling maintained from their siblings during every sampling event over time from the 17 to 55 day period. And what we saw was that fledglings that survived to day 55 on average tended to maintain a slightly lower inter-individual distance from their broodmates compared to fledglings that did not survive to day 55. However, the difference between these values is really, really low. So this indicates that there are likely other factors at play with a much stronger influence on fledgling survival. And now looking at distance from the nest versus fledgling age. Again, on the X, we have age in days, and on the Y, we have distance from the nest, again in meters. And what we found was that, as expected, age has a strong positive correlation with distance from the nest, meaning that as age increases, fledglings move farther from their natal nest. And more specifically, as fledgling age increases by 1 day, their distance from the nest where they hatched increases by just over a meter. So moving into my habitat use results, first up, we have their position in the vegetation by age. So on the Y, we have fledgling age in days, and on the X, we have 4 categories of fledgling position. And what we saw was that as age increases, fledglings tend to move up higher in the vegetation. So they're mostly found, and then we see a pretty large age range here for ground because this makes sense, right? As a fledgling first leaves the nest, they tend to go straight to the ground. And so if we saw a fledgling who really recently left their nest, then we would see them on the ground. And also fledglings that were older and bolder, we would occasionally see them begging for food from their parents in the middle of the road as well. Next up, for concealment versus age, we have the 4 concealment categories on the X here. And we saw that as age increases, fledglings do become significantly more exposed over time, with the youngest fledglings being the most concealed on the left and the oldest being the most exposed on the right. And lastly, for the scrub height surrounding the 5-meter radius of where each fledgling was found, we saw that compared to open sand, fledglings found in short scrub were about 11% younger, fledglings found in medium scrub were about 13% younger, and fledglings found in tall scrub were about 17% younger, indicating that younger fledglings do have a preference for taller vegetation in a significantly inverted relationship. So let's see how we did coming back to my predictions. All right, so we saw, or as a reminder, I had predicted that during the early fledgling period, we would have both low inter-individual distance and low distance from the nest, which we did in fact see. And as age increases, I predicted that IID would increase as well. And while we did see that it increased slightly with age, remember that this relationship was only marginally significant and that IID stayed relatively the same from day 17 to 55. But we did in fact see that there was a strong positive correlation between distance from the nest age. And then for IID and survival, recall that the difference in average IID between fledglings who survived to day 55 and those who did not survive was very low, which told us that other factors more strongly influenced survival. And then coming back to the predictions that I had for habitat use, I expected to see that as fledglings grew older, they would move up taller, higher in the vegetation, which we did in fact see, and that their concealment levels would also decrease, which we also saw. But for their scrub height, I predicted that it would become more variable, but that was not the case. We actually saw that there was we found that surrounding scrub height actually did decrease with age. And as a reminder, the youngest fledglings were found in the tallest scrub, while the oldest were found in shorter scrub and open sand. So considering these takeaways from my findings, this first and foremost emphasizes the importance of having patchy, diverse scrub with varying heights and densities of vegetation, because we saw that fledglings, different parts of the scrub were used by different age groups of fledglings, and that fledglings use their habitat differently than adults do. And this patchiness is achieved by having a mosaic in burns, so ensuring that fire does not burn too intensely and remove that scrub patchiness should certainly be considered. And lastly, having a better understanding of the factors that influence the survival, especially during such a highly vulnerable period, are essential to making more informed decisions regarding the protection and management of Florida scrub jays and their habitats. And with that, I would like to, first of all, thank the Bird Lab. It would have been literally impossible to collect almost 500 points of fledgling detections and find them every single day without your guys' help. So thank you guys so much for that and your support throughout this whole internship. And a special shout out to Esteban for many of the beautiful photos that he supplied, especially the title slide. As well as I'd like to thank the Archbold staff and of course my fellow interns and my lodge residents. You guys made this experience all the more memorable, and it was a pleasure and an honor living and working among you guys. I would also like to thank my family and my partner Kyle for their continued support. And of course, last but not least, the scrub jays. And with that, I will take any questions.
Excellent talk. Thank you. Just wanted to see what you think is causing mortality in the fledglings. Is it predation, or are they just kind of dying on their own, or how is well,
Yeah.
just dying?
Well,
living.
I definitely do believe that predation is the main cause of these fledglings dying. Yeah, so we were trying to understand like more so what affects whether a fledgling gets predated upon or not. But yeah, predation is by far the most dominant cause. The literature has also looked at whether fledglings are starving to death as well, which is not really nearly as much of an influence on their survival as predation is. So definitely.
You know what their predators might be, like snakes.
Yeah, definitely snakes, lots of snakes. Also, you know, birds of prey, raptors, but yeah, definitely ground predators are a huge threat to their survival.
Great talk.
Thank you.
I'm curious how you went about measuring all of the distances between all of the fledgling locations of the nests and the fledglings.
Yeah, sure. So let's see, like come back. Maybe it's gonna be going back a little far. So for first up with inter-individual distance. So we had the lat and long of every single point of the fledglings, and then I ran like pairwise every pairwise combination of those distances within each territory and sampling event. So each time that we went out to detect the fledglings from that same, I calculated the distance between them all. And then for distance from the nest, we also have the locations of all the nests on field maps as well. And I just found the distance from every single detection point and the nest where the fledgling.
So you did it in R?
Yeah.
Using the lat.
Yes. Yeah.
Thank you. Hello, were all the broods the same size?
All the broods? No, we definitely had broods of different sizes, ranging from fledglings that they were just the only individual in their brood. Of course, we couldn't include those in calculations of inter-individual distance because there's only one kid. But yeah, we had up to four individuals. There were some broods that had 5, but they never made it into the study. Unfortunately, they just didn't live that long. So
Okay,
yeah.
so the second question is perhaps related. Now, eventually you'll know what sex these individuals were, and maybe these data could be analyzed again based on males versus females, because there could be some dominance interactions going on.
Yeah, definitely. That's something that I wanted to look at going into it. And then, yeah, I was informed that we don't have that data until later on in the season when we get it back from the blood samples. But yeah, I was definitely curious to see like, are perhaps like males or females grouping together, or like, yeah, what those dynamics are like for sure. Definitely interested to see.
And finally, congratulations on gathering all of these data.
Thank you so much.
I can read them out. This will be online. Oh, okay. So Kyle goes, woohoo, go Sofia. Sean says, good work, very cool study and intensive field work, big data set. And Kyle also says, amazing presentation, proud of all the hard work.
Thank you. Thanks.
Does anyone have questions? All right, well, thank you so much, Sofia.
Oh, thank you guys.